Guys, welcome to my channel. In this video, I'll explain the breadth first search algorithm, which is uninformed search algorithm. And I'm making this video to help students who are preparing for GATE, competitive exams, interviews, and end semester exams. And I'll explain the working and principle of the breadth first search algorithm in a very basic manner, so anybody can understand. And you don't need any prerequisites to learn. Just believe me, guys, at the end of the video, you will become expert in breadth first search algorithm. Okay, guys, now let us dive into the video. What is uninformed search algorithm? So, uninformed search algorithm means we don't have any prior knowledge about the goal node. So, I'll explain using this example. Now, this is one of the binary tree, and this is initial node. A is initial node, and J is goal node. If we start from initial node, we need to reach the goal node J, but we don't have any prior knowledge. Like starting from here, we have two paths. One is this B, and one is C. So there is no parameter to say which path is better. Like we can easily say by seeing this graph, like going towards path C or next node C is better path compared to choosing B as the next node. But we don't have any parameter. The algorithm don't have any parameter to say this path is better than this path. This is what uninformed search algorithm means. So we need to explore each and every possible node until we reach the goal node. Now let us see how the breadth first search algorithm works. Breadth first search algorithm works uses a queue data structure. I think everybody knows about the queue data structure. It works on the principle of first in first out. The element which has entered the queue first will exit the queue last first only. Like first element entered the queue will leave the queue first. Okay. Now let us see how this breadth first search algorithm works. So let us see. First initial node is A. So the algorithm will enqueue A into the queue. Now it checks whether A is goal node or not. You can simply see like A is not the goal node. So the algorithm dequeues A and enqueues its children into the queue. Dequeues A and enqueues its children into the queue. B and C into the queue. Now B is the next element in the queue. So we can enter in any order like B and C and C and B. So the order does not matter. We can insert in any order. I just consider this order. Okay, now the element B is next in the queue. So the algorithm explores element B, node B. So node B. If we see node B, it is not the goal node. So the algorithm dequeues B. And again enqueues its children into the queue, which are nothing but D and E. Okay. Now C is next element in the queue. Now the algorithm explores node C. Again, node C is not the goal node. So the algorithm dequeues C and enqueues its children into the queue, which are F and G. Now the algorithm checks which element is next in the queue. So D is next in the queue. So the algorithm explores D. It checks whether D is goal node or not. So we can simply say like D is not the goal node, the algorithm dequeues D. Now it will check which element is next in the queue, which is nothing but E. And the algorithm starts exploring E. As E is not the goal node, the algorithm dequeues E. And also it don't have any children. So the algorithm will check next element in the queue, which is nothing but F. It will explore F. And as we can see, F is not the goal node. It simply dequeues F and inserts its children into the queue, which are H and J. So guys, one point you can observe, first the algorithm explored A and then it explored B and C. Now it is exploring E, D, E, F. G, and then it will explore H, I, J. Have you seen the order? If we compare it with the depth first search algorithm, the algorithm first explores the depth in case of depth first search. But in breadth first search, the algorithm starts exploring level wise. Like first it explored this level, next it is exploring this level, this level. So level wise. This is the difference between the depth first search and the breadth first search algorithms. Okay, now coming to the working of the algorithm. The next element in the queue is G. As G is not the goal node, the algorithm dequeues G, and as it don't have any children, next it will check which element is next in the queue, which is nothing but H. As H is not the goal node, the algorithm simply dequeues H, and the only element in the queue is J. So the algorithm will explore J. As J is goal node, then the algorithm gets terminated. This is the working principle of breadth first search algorithm. Okay guys, now let us see what are the drawbacks of breadth first search algorithm. The main drawback of breadth first search algorithm and all uninformed search algorithms are they are not optimal. Like we will be not able to find the shortest path from initial node to the goal node. We have to explore each and every possible node. Let us see with an example. So let us consider a small tree. So in this tree, let A be initial node. Initial node and F be goal node. Goal node. So we can easily see like the shortest path from initial node to the goal node is A C D F. But by using the breadth first search algorithm, we will explore each node level by level, whether it is goal node or not. So we have to explore first node A, then B, C, next G, D, and finally we will come to F. So we are not able to find the shortest path from initial node to the goal node. But the breadth first search algorithm is complete because anyway, even though it may take time or it will search all the nodes in the graph, anyhow it will find the goal node. That's why the algorithm is complete but not optimal. So and this is the drawback of breadth first search algorithm. Now let us see what is the time complexity and space complexity of breadth first search algorithm. So here I wrote first time complexity. So as we can see, the time complexity in case of a tree for breadth first search algorithm is, so to reach the goal node in worst case we have to explore all possible nodes in the tree. So the time complexity will be order of vertices, which means we have to explore all possible vertices in order to reach the goal node. That's why the time complexity is order of V. And in case of graph also same, like if we consider a complete graph, simply CD. This is a complete graph with four vertices. So A is initial node and D is goal node. So to reach the goal node from initial node, we need to explore all possible vertices. That's why the time complexity is order of vertices plus edges. Like we have to check all edges and vertices where our goal node is. And space complexity. When we see the space complexity in case of tree, it is order of W. Here W means width or number of nodes in the largest level of tree. Like let us consider a small example. So A, B, C, D, E, F, and G. So let us consider this graph. In this graph, let A is initial node and let us consider I as goal node. So as you remember, we use the queue data structure, like we will store the elements or nodes in queue data structure while using the breadth first search algorithm. Like the order, like with the nodes that are needed to be explored are stored in a queue. So when we start with A, in first level only we have one node, so that's why we store A in queue. Later we will store both B and C, and then we will store D, E, F, G, and finally H and I. So in worst case, like while exploring all possible nodes, if I find a solution after exploring all possible nodes in the graph, somewhere in worst case we will store all the nodes in this largest level. Like in this level there are four nodes are there, and this is the highest level with many nodes, so we need to store all the nodes in the queue. So that's why order of W, W means length of widest level. Here this is the widest level. Maybe if the graph is bigger, then this will be the widest level, like eight nodes will be there. So that's how it works. And if in case of a graph, we can simply consider previous example like a complete graph with 4 vertices or n vertices. So as the complete graph is connected, each node to other node, we need to store all possible nodes in the queue. This is the worst case space complexity of the breadth first search algorithm, both time and space complexity of breadth first search algorithm.